Lowe's knows how to help make your home holiday ready for less. Get Select Style Selections vinyl flooring for just $1.99 per square foot and have it installed before the festivities begin. Our team can help you every step of the way. See a Lowe's Red Vest associate or visit Lowe's.com/holiday install to get started. Lowe's, we help, you save. Basic install only. Date restrictions apply. Subject to availability. Installed by independent contractors. See associate for details. Contiguous U.S. only.
If you're shopping while working, eating, or even listening to this podcast, then you know and love the thrill of a deal. But are you getting the deal and cash back? Rakuten shoppers do. They get the brands they love, savings, and cash back. And you can get it too. Start getting cash back at your favorite stores like Levi's, Plow and Hearth, Adidas, Sephora, and Neiman Marcus. Stack sales on top of cash back and feel what it's like to know you're maximizing the savings. And it's easy to use. And you get your cash back sent to you through PayPal or check. The idea is simple. Stores pay Rakuten for sending them shoppers, and Rakuten shares the money with you as cash back. Download the free Rakuten app or go to Rakuten.com to start saving today. It's the most rewarding way to shop. That's RAKUTEN. Rakuten.com.
This is SpaceTime, Series 28, Episode 113, for broadcast the 19th of September 2025. Coming up on SpaceTime, the search for exploding black holes, an immense stellar jet seen on the outskirts of the Milky Way galaxy, and how do you prepare for an Earth observation satellite mission? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that astronomers could catch a black hole in the process of exploding. Some physicists have long believed that black holes explode at the end of their lives, and that such explosions happen at most once every 100,000 years or so. But now, a report in the journal Physical Review Letters claims there's a better than 90% probability that one of these black hole explosions might be seen within the decade. And if we're prepared, our current fleet of space and earthbound telescopes could actually witness the event. Such an explosion would be strong evidence of a long theorised but never actually observed object called a primordial black hole. These are black holes that formed less than a second after the Big Bang 13.8 billion years ago. And furthermore, these explosions would give astronomers a definitive catalogue of all the subatomic particles in existence, including both the ones we've observed, such as electrons, quarks, and the Higgs boson, and the ones we've only ever hypothesized about, like dark matter particles, as well as everything else that is so far entirely unknown to science. This sort of catalogue would finally answer one of man's oldest ultimate questions. From where did everything in existence come? We know black holes exist, and we have a good understanding of their life cycle. An old massive star runs out of fuel and eventually implodes into a massively powerful supernova that leaves behind an area of space-time with such intense gravity that nothing, not even light, can escape. These black holes are incredibly heavy and essentially very stable. But back in 1970, physicist Stephen Hawking claimed another kind of black hole, a primordial black hole, could be created not by the collapse of a star, but from the universe's primordial conditions shortly after the Big Bang. Primordial black holes, like the standard stellar mass black hole we mentioned earlier, are so massively dense that almost nothing can escape them, which is of course what makes them black. However, despite their density, Hawking believed primordial black holes could be much lighter than the black holes we've so far encountered. Furthermore, Hawking believed that black holes had a temperature and could in theory slowly emit particles through a process called Hawking radiation. That's if they got hot enough. Hawking radiation occurs when two quantum particle pairs pop into existence right on the event horizon of a black hole. But these quantum particle pairs would annihilate each other virtually immediately. But if one of the quantum particle pairs was on one side of the event horizon and the other quantum particle pair was on the other side, then the one on the black hole side of the event horizon would disappear forever into the black hole singularity, leaving the one in our universe to float away, evaporating part of the black hole. Now, one of this study's authors, Anthea Thame from the University of Massachusetts Amherst, says the lighter a black hole is, the hotter it should be, and the more particles it will emit. As primordial black holes evaporate, they would become even lighter and so hotter, emitting ever more radiation in a runaway process until they eventually explode. Thame believes it's that Hawking radiation that telescopes should be able to detect. The problem is no one's ever actually directly observed a primordial black hole. But this new hypothesis suggests there's up to a 90% chance of witnessing an exploding primordial black hole in the next 10 years. The work's all based on a dark QED model. This is essentially a copy of the usual electromagnetic force, but which includes a very heavy hypothesized version of the electron, which Thame and colleagues call a dark electron. Now, with this dark electron, the authors could reconsider long-held assumptions about the electrical charge of a black hole. Standard black holes have no charge, and it was assumed that primordial black holes would likewise be electrically neutral. But the study's authors are making a different assumption. They believe that if a primordial black hole is formed with a small dark electric charge, then the model predicts it should be temporarily stabilized before finally exploding. Taking all experimental data into account, they find they could even then potentially observe a primordial black hole explosion, not once every 100,000 years as previously thought, but once every 10 years. Now, the authors admit they're not claiming that it's going to absolutely happen for sure sometime in the next decade, but they believe there's a 90% chance that it does. And since we already have the technology to observe these explosions, we need to be ready for them. If it happens, it would be the first ever direct observations of both Hawking radiation and a primordial black hole. And it would also provide definitive proof of every particle that makes up everything in the universe. It would completely revolutionize physics and help astronomers rewrite the history of the cosmos. This is SpaceTime. Still to come, astronomers discover an immense stellar jet on the outskirts of the Milky Way galaxy. And how do scientists go about preparing for an Earth observation satellite mission? All that and more still to come on SpaceTime. Astronomers have discovered an immense stellar jet blasting out into deep space from the outskirts of our Milky Way galaxy. The huge fireworks display, catalogued as Shapless 284, is being generated by a massive young star still in the process of forming. It's producing seething twin jets of hot plasma, blazing across some 8 light years of space. That's twice the distance between our Sun and the nearest neighbouring star system, Alpha Centauri. It's caused by superheated gases falling onto the massive star and being blasted back into space along the star's rotational axis, with powerful magnetic fields confining the jets to narrow beams. These jets are then ploughing into interstellar gas and dust, creating fascinating details which are being captured by NASA's Webb Space Telescope and witnessed in infrared light. Astronomers say the sheer size of this cosmic blowtorch of seething gases erupting from the still-growing monster star qualifies it as extremely rare. The outflow is streaking across space at hundreds of thousands of kilometres an hour. The central protostar, which has at least 10 times the mass of the Sun, is located some 15,000 light-years away in the outer reaches of the galaxy. The study's lead author, Yu Cheng from the National Astronomical Observatory of Japan, says the Webb discovery was serendipitous. Astronomers had no idea there was a massive star of this kind out there, and no idea that there was a super jet outflow from it. That was until they saw it. Such spectacular outflows of molecular hydrogen from a massive star are very rare in other regions of our galaxy. This unique class of stellar fireworks, known as Herbig-Haro objects, are highly collimated jets of plasma shooting out from newly forming stars. You could think of these jetted outflows as being the star's spectacular birth announcement to the universe. Well over 300 Herbig-Haro objects have been observed so far. They're almost all coming from low-mass stars. And for astronomers, whether they're from big stars or little ones, these spindle-like jets are fascinating. They offer new clues about the nature of newly forming stars. Their energetics, their narrowness and their evolutionary timescales all serve to constrain models of the environment and physical properties of the young stellar objects powering these outflows. This new detection offers evidence that Herbig-Haro jets must scale up with the mass of the star powering them. The more massive the stellar engine propelling the plasma, the larger the star's size. This jet's detailed filamentary structure captured by Webb is evidence the jet is ploughing through interstellar gas and dust, in the process creating separate knots, bow shocks and linear chains. The tips of the jet, lying in opposite directions from the central star, encapsulates the history of the star's formation. See, originally the material would have been very close to the star, but over the past 100,000 years, the tips have propagated outwards. At nearly twice the distance from the galactic centre of the Milky Way as our Sun is, the host protocluster that's home to this voracious jet is on the very periphery of our Milky Way galaxy. It's within a cluster containing hundreds of stars that are still forming. But being in the so-called galactic hinterlands means the stars are deficient in heavier elements beyond hydrogen and helium. In astronomy, all elements heavier than hydrogen and helium are considered metals. And the amount of metallicity a star contains gradually increases over cosmic time as each passing generation of stars expels the end products of nuclear fusion through stellar winds and supernova explosions. And so the low metallicity of Sharpless 284 is a reflection of its relatively pristine nature, making it a sort of local analogue for the environments of what the early universe was like, an environment that was also deficient in heavier elements. Webb's observations are also showing that relatively more stars seem to form at lower masses in Sharpless 284 than in closer, more metal-rich clusters. Massive stars, like the one found inside this cluster, have very important influences on the evolution of galaxies. Cheng says the discovery is shedding new light on the formation mechanism of massive stars in low metallicity environments. So astronomers can use this massive star as a sort of laboratory to study what's going on in earlier cosmic history. The stellar jets are powered by the gravitational energy released by the star as it grows in mass, and they encode for the formation history of the protostar itself. Webb's new images are telling astronomers that the formation of massive stars in such environments could proceed through a relatively stable disk around the star that's expected in theoretical models of star formation known as core accretion. Once they found a massive star launching these jets, the authors realized they could use the Webb observations to test theories of massive star formation. So they developed new theoretical core accretion models that fitted the data to tell them what kind of star was at the center. And these models implied that the central star would be about 10 times the mass of the Sun, and it's still growing. For more than 30 years now, astronomers have disagreed about exactly how massive stars form. Some think a massive star requires a very chaotic process called competitive accretion. Now, in the competitive accretion model, material falls in from many different directions, so the orientation of the disk changes over time. The outflow is launched perpendicularly above and below the disk, and so it too would appear to twist and turn in different directions. However, Webb has shown that the opposite sides of the jets are nearly 180 degrees apart from each other, and that tells astronomers that the central disk is being held steady and therefore validating the hypothesis of the core accretion model. This is SpaceTime. Still to come, preparing for an Earth observation satellite mission, and later in the science report, a new study shows that people who engage in hate speech have similar patterns to people with psychiatric disorders. All that and more still to come on SpaceTime. Developing a space mission is a long process. It involves lots of tests and sometimes very harsh environments. A good example of this was an airborne campaign recently carried out in the Arctic between Greenland, Iceland and Svalbard. The campaign was carried out under the auspices of the European Space Agency. Scientists involved in the project had to endure temperatures of 30 degrees below zero. They were testing an airborne version of a new imaging microwave radiometer designed to support the development of a potential satellite mission for the European Copernicus program. This report from ESA TV.
Inside this small plane at the airport of Longyearbyen, one of the most northern cities in the world, is an instrument that is helping to define a future space mission to better understand our planet. In the extremely harsh conditions of the Arctic, engineers and scientists are testing a microwave radiometer, an instrument that is able to monitor sea ice and its evolution.
The radiometer just senses, it reads basically the sea ice, so at certain frequencies. And from that, actually breaking down into several different frequencies, you can actually study the sea ice signatures. And from that, then you can infer what kind of sea ice you have. And also from that, you can infer how old the sea ice is, for instance.
The information on sea ice characteristics from this airborne campaign is being used to support the Copernicus Imaging Microwave Radiometer, one of the 6 high-priority candidate satellite missions being studied for the European Union's Copernicus system. This is a difficult activity, but necessary to be sure that if the mission is selected to go into space, scientists will be able to retrieve the high-quality data they are looking for.
This instrument that we're flying has been around for many years already, and it had to be completely renovated in order to fly again. And we're testing it now for the first time because we want to obtain the sort of data that the satellite will see later on, and really answer some scientific questions we have in the meantime. So with this data that we're going to collect here.
This is how many operational Earth observation missions are created, a policy need that leads to the development of a tool able to give the best scientific measurements. The results on concentration and distribution of Arctic sea ice will contribute to the larger question of climate change and how the Arctic environment is affected by this global phenomenon.
The sea ice is strongly changing. You can see that parts of Svalbard, which were earlier ice covered in winter, like the fjords just out here, they are not ice covered anymore. And that in the Arctic Ocean, of course, in the summer there's much less ice, and that is the very important thing to follow by the present mission, the SIMMER, which we fly for right now, and also for the future.
This Arctic airborne campaign to help prepare the Copernicus Imaging Microwave Radiometer is part of this quest to obtain more accurate data, providing hard facts on the evolution of ice coverage, one of the key elements to understanding climate change and its impact on Earth. All part of the integrated European policy for the Arctic.
And in that report from ESA TV, we heard from ESA Scientific Campaign Coordinator Tina Cassell and Renee Forsberg from Denmark's National Space Institute. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new analysis of 54 Reddit communities has found that posts in hate speech communities tend to share similar speech patterns with posting communities for certain psychiatric disorders. The findings, reported in the journal PLOS Digital Health, used artificial intelligence to analyse posts relevant to hate speech, misinformation and psychiatric disorders. For neutral comparisons, communities that fall under none of those categories were also included. The authors say that while the findings don't suggest that people with psychiatric disorders are more prone to hate speech or misinformation, they could help inform new strategies to combat these online, such as using elements of therapy developed for psychiatric disorders. Well, after decades of research, a chlamydia vaccine has finally been approved for koalas. The chlamydia virus causes debilitating blindness and infertility among the marsupials, and it's rampant in some koala populations, especially on parts of the New South Wales north coast where the arboreal marsupials are already threatened by habitat loss, wildfires and roadkill. The new vaccine reduces infection, prevents progression to clinical disease, and in some cases even reverses existing symptoms. However, rolling out the vaccine into a wild animal population won't be easy, and there are now calls for government funding to help inoculate at-risk koala populations. A 67-year-old man is still alive more than 6 months after receiving a kidney from a genetically modified pig. A report in the journal Nature claims it's now the longest pig organ survival time in a living human. The transplant surgeons say that passing the 6-month mark is a sign that things have gone extremely well, as this is the highest risk period for both the recipient and the transplanted organ. And now it's time for our silliest story of the week. And claims of an alien UFO base in Alaska, mentioned in a declassified CIA document, have apparently fueled a surge in sightings. But as Tim Mendham from Australian Skeptics points out, the CIA has never confirmed the alien base is there. And the document itself dates back to the 1970s when a remote viewer was given unknown targets, then asked to describe what they perceived.
This is an old document. We're talking back from the 1970s. It's come to light fairly recently-ish, and then it's now being promoted and publicised in the media as a description of a alien UFO type base in what's called the Alaska Triangle. Now, you have to realise that every country has to have their triangle. Bermuda Triangle started off. There's a Japan Triangle. There's an Alaska Triangle. I think there's one in Yorkshire, in the UK Triangle. I think if a country's not complete unless they have some alien paranormal triangle. So
Australia doesn't have one. That's really
I don't
sad.
think it does. I'm trying to think. Well, it's about time we did, I think. I think we're deprived. Why a triangle? Why not a square or a rectangle or a dodecahedron or something? I don't know why a triangle is so important. Anyway, this is a UFO base supposedly on a place called Mount Hayes in the Alaska Triangle.
Lots of Sasquatch found there as well, apparently.
Yeah, there's lots of everything, apparently. I would have thought Sasquatch would be a bit cold up in Alaska, but never mind. But yes, this is supposed to be a remote viewer who's a psychic who can see things far away and describe them. Apparently, one of the pictures he drew had something that looked like a mountain, so then instantly it becomes sort of a mountain in Alaska. There was these alien creatures around. He could see incisors, etc. The CIA at that time was investigating anything and everything that might give them a military advantage, and that included psychic powers and seers and remote viewers and clairvoyance and all sorts of things, just to see if there was anything there. And they ran with this for a decade or so until they were probably eventually cancelled because there was nothing there worth bothering about. So therefore, this is just one guy who is a remote viewer, can see things from far away, said he found this, filed away in a filing cabinet somewhere, released again some years later, sort of like, look at this.
The same sort of spiel as we had with the Lost Ark of the Covenant.
That's right. It's exactly the same thing. But the trouble is it's unproven. They didn't find it. I don't know if they did any investigation to find it. I don't know if they believed him. I mean, I could say I've had a remote viewing of leprechauns in the bottom of my garden. And if that was it, would you say that's true? Or would you say probably not? Or prove it? But no one seems to be saying prove it to this one. They're just saying this fellow drew the results of his remote viewing, therefore it must be true. This is an old document that's been released a number of years ago and people have picked it up and all it is someone saying that they saw this and they wrote it down. It's not even very detailed. It was never substantiated, never investigated as far as I know. And there's no evidence that what the person saw was ever real. And yet people are now quoting it as a real document that shows something real. Show me something better, please.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Chances are you've been to the doctor recently and you probably handed over your insurance, your ID, and even your social security number. Your doctor is just one of many places that has your personal info. And if any of them accidentally expose your details, you could be at risk for identity theft. LifeLock monitors millions of data points a second. If you become a victim, they'll fix it, guaranteed, or your money back. Save up to 40% your first year. Call 1-800-LifeLock and use promo code IHEART or go to lifelock.com/iHeart for 40% off. Terms apply.